Hello once again, students. Welcome to this YouTube learning channel, the Gillespie's online classroom. My name is Derek Gillespie. I'm a teacher in Jamaica, teaching specifically at Monroe College. This teaching video was created specifically for students of fourth form who are doing CXC or CSEC geography. And in this particular video presentation, we will be focusing on the topic or the theme of study, the weathering of rocks. Come with me now as we explore this topic as you prepare for your CSEC or CXC exams. Okay, before we begin the topic officially, let's zoom in on the objectives of this particular lesson as it relates specifically to the objectives of the CXC syllabus. Now, at the end of this teaching video, we are hoping that CSEC students of geography will be able to understand and clearly define and express the term weathering. We are hoping that you will be able to understand and differentiate between the three categories or groups or types of weathering, namely physical, chemical, and biotic, also called biological, also called organic weathering. We are hoping that at the end of this teaching video, you will also be able to distinguish between the various types of specific processes of physical weathering, chemical weathering, and various examples of or processes of biological weathering. Now, here is an exam tip for students who are preparing for CSEC or CXC exam in this topic. Please make sure, as you can see on screen, that you do not confuse the categories or groups or types of weathering, physical, chemical, or biotic or biological weathering, with the specific processes or types, not types, examples or the specific ways that the various categories of weathering can occur. So whether it be by frost action or exfoliation, as you will learn later on. So keep in mind that there's a distinction between categories or groups of weathering and the specific processes or the way in which these categories or groups of or types of weathering can occur. Now, as we delve into the topic, it will become obvious that there are two other natural environmental processes, or should I say phenomenon, or actions in the environment which take place naturally, which can be confused with the process of weathering. Look out for words like erosion, transport, and be careful not to confuse erosion with weathering. As I analyzed carefully certain teaching videos online from many places, I noticed that teachers in some parts of the world tend to confuse the concepts of weathering and erosion. And so before we actually go into the topic weathering, we need to distinguish between these two concepts or phenomenon, weathering and erosion, and to a lesser degree, transport of material. So let's do that now before we actually go into the topic of weathering.
When you weather a rock, you take a large piece of rock and you break it down into smaller pieces of rock called sediments. There's a couple different ways you can do this. If you want to do this physically, like actually break apart a rock, whether you're Bugs Bunny or whether you are a river or a glacier or what have you, if you're taking a large rock and physically breaking it apart into smaller pieces, then you are doing what's called mechanical weathering. That's one type.
Now, it needs to be made clear here that when weathering takes place and the rock is broken into smaller bits and pieces, there is no movement of that material or those pieces from one point to another. It happens in one spot at the same place where it occurs, and so there's a term for this. It's called in situ, in the same place. Keep that in mind. Weathering does not involve the movement of the material which is broken off from the larger mass of rock. Keep that in mind.
Of weathering. But you can also take a rock and dissolve it chemically. This happens with limestone all the time. One of the reasons why acid rain is so damaging to certain buildings and structures is because it actually contains enough acid to just start to barely dissolve up the limestone that's found in a lot of ancient sites. This is called chemical weathering. But regardless of whether you're doing mechanical weathering or chemical weathering, the end result is that you have sediment. You take a large chunk of rock, you break it up, and you end up with sediment, smaller pieces of rock like sand or pebbles or gravel. Next, let's talk about erosion. Erosion is what happens when sediments are moved to a new location. So in weathering, we broke up a rock into sediments. Now we're going to move those sediments someplace new. This can happen through water, rivers, waterfalls. The ocean can move sediments around. It can happen through wind. Wind can blow sediments around, especially in desert areas. And it can happen simply through gravity. A great example of how gravity can move sediments is Yosemite Valley. Yosemite Valley has very steep sides, and they have rock falls all the time. And those rock falls are caused simply by gravity. And if you get a big enough erosional event, well, then you get to have a landslide. Landslides are like erosion on steroids. It's erosion gone crazy. But either way, the end result, whether you're using water, wind, gravity, or a combination of all three, you end up with sediments in motion. Let's move on next to deposition. In deposition, those sediments are dropped in a new location.
Okay, so I would like to pause here to indicate that before you get into the study of weathering, keep these three concepts in mind and do not confuse them. Weathering, rocks break apart naturally by the various agents of nature, but the material that is broken apart or the rock that is breaking down does not move. That's weathering. Once the material starts to move, whether by running water, moving material from one point to another, or by wind, or by glaciers, meaning ice slowly scraping and moving across the land, once there is movement, or the waves of the sea moving material like sand from one point to another, that's erosion. Eventually, the material can be laid down, and that's deposition. Now, these activities occur together, but they are not the same thing. So careful that you don't mix up weathering with erosion, even though these activities in nature which occur naturally, they often occur together. So with that in mind, we can now delve into the study, and I'm going to allow our fellow geography teacher right here in the Caribbean to assist us in the details of this lesson.
So the syllabus specifically asks us to look at the location, the process, and the result of chemical weathering, physical weathering, and biological weathering. For chemical weathering, they ask us to look at hydrolysis and carbonation. Usually as teachers, we teach oxidation as well. but the syllabus specifically asks for hydrolysis and carbonation. Physical weathering, they ask for frost action and exfoliation. Sometimes we teach other things too, but the syllabus specifically asks for these two. And then biological, we just teach biological itself. Okay?
Now, seeing that I am being assisted by this particular website and this particular geography teacher, who calls herself Mrs. G. There you see her website on YouTube, her channel. Feel free to subscribe and to join up to this particular website that I am using material from to assist your learning. And so I give full credit to this website, this YouTube channel, Caribbean Geography with Mrs. G. Feel free to subscribe. So we now allow her to take us through the lesson.
So, weathering. There's a song about weathering that I like, but it's super old. It says, you know about weathering, break down that rock with weathering. The thing is, that's all the song is saying, so I didn't put it in there. Anyway, the point is that weathering is the breaking down of rock. That's a simple definition that you can use. But what is more important is that you include this. In situ. Syllabus asks us to include that. So if you get a question that is asking you to define weathering, do not just say weathering is the breaking down of rock. You must include the fact that weathering is the breaking down of rock in situ. So that means it is in its original place. There is no movement with weathering. Weathering itself does not move anything. That's another process entirely. Okay? So weathering itself, all it does, it breaks down the rock. All right, so the rock does not move while it is being broken down. So now we have different ways that the rocks will break down. That is how we have the physical weathering, chemical weathering, and biological weathering. So from those three words, physical, chemical, and biological, those can already give you a pretty good idea of how the rock is going to be broken down. And it's easy for you to define them too. Because once you already know what weathering is, then it's easier for you to break down the others and come up with your own definition if you don't remember the exact definition that you were given in class, right? So physical weathering. This refers to the physical breakdown of rock without a change in the mineral composition of the rock. So when we say mineral composition, what we're talking about? Let me give you an example. So I have an Oreo right now, right? Biscuit. No, let me use crackers. So I have a crackers. I have Excelsior crackers. Most of you are Jamaican. So I have Excelsior crackers, and I'm about to put it in my. What you put your crackers in? You put your crackers in tea or porridge or what? Porridge. All right. So I'm about to put my crackers in my porridge. I don't want to put it in there whole. So I start to break up my crackers, and drop it in the porridge. So the breaking up of my crackers in my hand, that is me physically breaking down my crackers, making it into smaller pieces, but I have not changed the mineral composition of my crackers. I don't change nothing about my crackers except the size, the physical size. Understand me? So physical weathering is the physical breakdown of the rock without changing the mineral composition. We also call physical weathering mechanical weathering. So anyone they use on the exam, you should be able to understand what it is. So This just causes the rocks to be broken down into smaller pieces. No chemical changes would take place. So we have different types of physical weathering. We have, well, the types that they ask us to look at. We have frost action and we have pressure release, which is also called exfoliation. So the syllabus specifically asks us to look at, hang on, what it is. All right, so here, the location of it, where it can be found, what is happening, and what it results in, right? So those are the specific things that we're going to look at. So the first one is frost action. So from here, frost, what that mean? What that sound like? Yeah, ice, good. So it's cold. So we already know just from the name of it. Frost action. It's also called freeze-thaw action. We already know that this is happening in cold areas. Yeah? So frost action, this is the form of weathering that is also known as freeze-thaw action. Where it happens, we also call it frost wedging as well. So from you see the frost, you know what we're talking about. You know that it is the cold one relating to ice. All right?
Now, I'd like to pause the presentation by my fellow teacher here to indicate that all geography students should, at this point, pull out your atlases and ensure that you look at areas with temperate climates. In other words, areas that are not extremely cold, like closer to the North Pole, and areas that are not extremely hot, like areas in the tropics. So you're looking for those in-between areas, parts of United States, parts of Canada, parts of Asia, that are in between these two extremes. So you will have extreme change from one season, such as summer, to the next extreme season, winter. So you have these extremes, but you don't have the temperatures remaining very high throughout the year or very low throughout the year. So there's a change back and forth. So these are the general areas where the frost action type of weathering or weathering process, a type of physical or mechanical weathering, takes place. So use your atlas to guide you and look for the temperate climates, both above the equator as well as below the equator. Temperate climates. And that's generally where you'd find frost action taking place.
It's fluctuating. What does fluctuating mean? Yeah, here where the temperature is high at this minute, not really this minute, like it's high today, and then tonight it's really, really cold or low, and then it's cold, hot, cold, hot, cold, hot. So it's not stable, right? So it occurs in these areas around 0 degrees. So 0 degrees, we know that that is freezing point. So we have freezing taking place and then thawing taking place. Freezing taking place and then thawing taking place. So that is where the frost action comes in. So before we look into the how it happens, yeah, I want you to think with me. I like using real life examples that you can actually relate to. So it helps you to understand it in your exam, right? So if you're going there and you forget certain things, you can still remember what happened in your kitchen, for example. So let us say we put a bottle in our freezer. Full 1 bottle of water, put it in the freezer. We leave out, go school and leave it in there. Come home, we'll not take it out because we'll use it tomorrow morning. Tomorrow morning, we leave out, go school and leave it in there again. What's going to happen to your bottle? To expand, yes. So my bottle is going to start getting bigger. My bottle going to start stretching. Right? So that is the expansion that is taking place. Same thing with my rock. So if I take out my bottle and it thaw out, and I put in back the bottle and it freeze again, and take it out and it thaw out, put it in and it freeze again, the bottle is going under pressure. The bottle is under pressure. So this minute it contracting, the next minute it just getting wider. The next.
I should probably point out here that this happens, of course, as the seasons change from the cold period where water can settle, from the summer period where water settles in rocks, through to the winter period when the water that is settled in the cracks of rocks will expand as it forms ice and therefore puts pressure on the cracks and break the rock into smaller pieces. And of course, as the summer comes, the ice melts and the water will sink further down into the cracks in rocks. And the process repeats itself from season to season. And so this is the principle that is being explained here by this fellow CXC teacher. We continue.
It getting smaller, etc. So the freezing and the thawing puts pressure on my bottle. And as somebody said before, eventually my bottle is just going to burst. Right? Same thing happens with frost action. So because we said this happens in areas where the temperature is fluctuating, meaning it up, down, around 0 degrees. So this minute it freezing, next minute it not freezing. So water will find its way into little cracks that are inside the rock. So these cracks that are inside the rocks now, that may be very, very small. Once the water finds its way in there, when the temperature drops, when my temperature drops and it gets really, really cold, this water that I have inside my rock is going to freeze. And the freezing causes it to expand or causes it to widen. Then, when my temperature rises and it gets warm, my ice that is now inside my rock is now going to melt. So I will have my water in there again. So then it is going to contract. So this process that is repeated over and over, it is going to, just like the bottle in the freezer, it is going to cause my rock to be shattered. My rock is just going to burst or fall apart. So this is what it would look like. So my water fills up a crack that is inside my rock. It freezes to ice, expansion is taking place, and because of that expansion, it causes my rock to break apart. Next one is pressure release. Remember when we spoke about the sedimentary rock, and we spoke about the layers that are there, but once you have something that is constantly on it, it's pressured and compacted. Do you remember that?
Yes, miss.
All right. So this is a little similar. The only thing is that it's not water that we have. It's overlying rock. So we have our rocks that are below the Earth's surface. For example, if we have some intrusive igneous rock, because it is intrusive and because it has cooled and hardened below the Earth's surface, we would have things on top of it, constantly pressing it down, constantly pressing it down. When those things are removed, when those things are now exposed, then our rock now it's almost as if it finally has a chance to breathe. So it's like if you're coming from foreign and you're packing your suitcase, right? And you push it on, push it on, push it on, push it on, push down everything, because you want everything fit until the suitcase finally zip. Whenever you open back that suitcase, everything that is inside, it's almost as if it's going to take back its form. So it's going to just rise up. And then you might start saying, oh, all of this did fit. It's the compaction process that it would have gone through. So for pressure release, it's kind of the same. So this form of weathering is also known as exfoliation or onion peeling. You see, like how with onion, you have the layers, the different layers. And like with exfoliation, when you're exfoliating your skin, ladies, well, gentlemen too, you are just rubbing to get off the dead skin off the outside of the layers. It's a similar situation. So how this one works is that the overlying rock is removed by erosion or whatever natural process. So it causes the rock that was underneath under all this pressure to now be released. So when this rock is now released, it causes the rock to finally expand, just like the closing of the suitcase. It causes the rocks to finally expand. So this expansion now, it causes it to just crack. It causes it to crack, but it cracks in a parallel way. So it's just like you're peeling off the parts of an onion. So how you have this layer, you take off it, and the next layer look the same and you take off it. Next layer look the same and you take off it. Similar situation here. So this causes the rocks to develop several layers which are similar to that of an onion. So over time, these sheets of rocks will break away from the rock mass itself. So this is what it would look like in real life, right? So you would have, this is my underlying rock here. Well, all of this was once underlying rock, but everything that is on top of it has been removed through erosion. So because this rock is now exposed, it's exposed to the wind, it's exposed to water, etc. It starts peeling off in little layers. Do you see how they look? They have the same shape as the underlying rock, but it's almost like you're lifting off a top part of it. Do you see that? All right, so that is how that process works. That is why we call it exfoliation. So imagine that you're rubbing your skin and you're taking off those outer layers, but eventually something else is going to come back and you're taking off those outer layers just the same. So overburden rock is eroded, so the amount of pressure that would have been on the rock that's underneath, it would have been removed. Once it's removed now, it's like the rock can finally breathe. So it expands, and that is when the cracks develop, and that is when this rock starts breaking apart. So notice with those two that we did, with the frost action and with this pressure release, the chemical composition of the rock does not change. All that we have done is broken up the rock into smaller pieces of the same thing. So this is another one that we look at as well, temperature change. Temperature change is somewhat similar to frost wedging, frost action. So this happens though in areas that are very, very hot instead, such as the Sahara Desert. So they have large daily range of temperatures. So
now I'd like to point out here that in the desert areas like the Sahara Desert, where there is an extreme change of temperature between the day, very high temperatures, and in the night it drops to very low temperatures. This area is considered to be, the term we use in geography is that it is hot and dry, and the term that is used for that is that it's arid. Arid areas, hot, dry, dusty. And so normally you have in the day temperatures reach very, very high levels, and in the night you have the temperatures drop to very low levels where you can literally freeze in a desert during the night. And because of these extreme changes of high and low temperatures, you end up having the expansion and the contraction of the outer layers of rocks. So the rocks will eventually shell off because of this expansion and contraction. Same kind of exfoliation, removal of outer layers that you heard earlier with pressure release. When pressure is released, the outer layer of rocks expand and crack and break apart. We continue.
In the deserts, people know the deserts as being really, really, really hot. But they don't know that in the nights, the desert is really, really cold. Extremely cold. So it is a large variation. It's very different temperatures between the day and in the night. So during the day, the temperature is high. There's no water in the rock like frost action, but the high temperature itself causes the rocks to expand slightly. During the night, you have the low temperatures. It causes the rocks to contract slightly. So it's like breathing up, down, up, down, up, down, up, down. So every night is one way, every day is another way, every night one way, every day another way. So this repeated expansion and contraction causes the cracks to form in the rocks. So eventually, they just burst and fall apart. So this is what it would look like. So chemical weathering now. Let's go back to the crackers. So the crackers in the porridge. So with physical weathering, I break up my crackers and I put it inside my porridge. With chemical weathering now, I don't break up my crackers. I just take the entire crackers and put it inside the porridge. What's going to happen to the crackers? Going to get softer. Good. What causes it to get softer? If you notice now, my crackers would now have a different chemical composition. So I have broken down my crackers just the same. It has gotten broken down inside the porridge, but it's broken down in a different way. So the chemicals would have acted on the crackers, causes it to soften, which really is still weathering it. It's causing it to break down, right? So physical weathering, I would have just broken down my rock without changing the chemical composition. Chemical weathering, I am breaking down my rock, but I am altering the chemical composition of it. I'm changing the actual makeup of it. It is some reaction that is actually causing the rock to break down. So we have a change in color, texture, or the actual makeup or the form of the rock that causes this rock to be broken down as a result of some chemical that has been released, right? Do we understand the difference between chemical and physical weathering?
Okay, so let me make a comment here that when it comes to chemical weathering, you now have the actual molecules that make up the rock, the compounds that comprise the rock overall. They are being altered and changed by a chemical reaction. So the rock is actually going to break apart at its chemical makeup. So it's not just a reducing of the size of the rock mass, but now the rock is being altered by color, by texture, by composition. And so the rock is weakened chemically, changed at its compound level. And once the rock weakens chemically, then it will easily crumble and fall apart. A term which is called decomposition. Notice the term. Composition, makeup. Decomposition, you're reversing that chemical makeup of the rock, so the rock weakens and fall apart. We'll allow the teacher to continue the lesson.
So for chemical weathering, there are different types as well. The syllabus specifically asks us to look at hydrolysis and carbonation. So there are other types. Most times teachers may teach oxidation as well, but the syllabus specifically asks us to look at hydrolysis and carbonation. So those are the two types that we are going to be looking at.
My advice to geography students is to make sure that you know all of the chemical processes of weathering: hydrolysis, carbonation, hydration, simple solution, oxidation. Know all of them, because you never know what will appear in the multiple choice paper. But as it concerns essay writing, in terms of the paper 2, you will be focused more so on the processes that were mentioned by the teacher earlier. But my advice, know all of them. Do not ignore any of them for the sake of multiple choice paper, and making sure that whatever CXC throws at you, you know as it concerns the weathering process.
So hydrolysis. Look at the word hydrolysis. What's the root word in there? Or what's the prefix? What's the prefix in the word?
Hydro.
Hydro. Good. What does hydro mean?
Water.
Yes. So, one form of chemical weathering is hydrolysis. So we have the acid in water that is working to dissolve minerals within specific rocks. So it's not like it's every rock this going to happen to. So if we have acid rain, for example, that's falling outside, it doesn't mean that every single rock that is outside is going to just start eroding, or every single rock that is outside is just going to go through that particular process of chemical weathering. It doesn't mean that. So it acts on the minerals within specific rocks. This is how it happens. So hydrolysis is the reaction of a substance with water. So the rainwater mixes with the carbon dioxide and it forms acid rain. It forms a weak carbonic acid, right? So this acid reacts with the minerals in the rocks and it causes them to dissolve. So for the hydrolysis, sometimes we refer to it as solution. This changes the chemical composition of the rock and causes them to be broken down. Rocks that are high in minerals such as feldspar would dissolve to produce clay, and the process would also turn sodium minerals into saltwater solutions. So the rainwater is basically selecting what type of rock it affects and what specific mineral inside the rock is affected. So it doesn't mean that the rock itself is just going to wither away and you see nothing at all. It doesn't mean that. All of the other minerals that are in the rocks would have been left standing. So look at the picture that we have here. You can see that only some sections of this particular rock has been broken down, right? You can see that only some sections have been broken down. Not all of it is made up of the same material, so it has altered the chemical composition of the rock. So these areas that it affects specifically, these areas would have been broken down. So eventually, because you have the rock looking like this, eventually more of it will break down just the same. So the next form, well, CXC did not specifically ask for this, but, you know, another form of weathering is oxidation. So oxide, iron oxide. So this, in this case, the combination of a substance with oxygen. So oxidation is the reaction of a substance with oxygen. Remember, hydrolysis is the reaction of a substance with water. Oxidation, reaction of a substance with oxygen. So the oxygen in the acid rain will react with iron present in rocks. When the irons in rocks react with oxygen, it forms iron oxide, which weakens the rock. So like, maybe if you're at school or if you're at home, if you have a grill or something, most times I see it at school. I don't really see it at home. Like on the railings at school, when you hold on to it and and you look at your hand, you see rust. Do you see that sometimes? So it would have been basically the rain or the oxygen that is reacting to the iron, which weakens it and causes the rust to take place. So similarly with oxidation, the oxygen reacts with the iron that is inside rocks and causes it to break down. So we get that brownish reddish color, kind of like what we see in there. So it's almost like the rock is rusting. You see sometimes some old truck park out in some place where water can touch it consistently and the oxygen, and then it causes that to rust as well. So it's just the iron reacting with the oxygen. Another form of chemical weathering is carbonation. So we can see the carbon in this one as well. Carbonation, which is the process of carbon dioxide dissolving in a liquid. So look at what we have here as well. So again, just like hydrolysis, it's not as if it affects all of the rock where everything is dissolved. It affects the part that it can affect, and it will leave the rest of it standing. So you will have all of these holes in this particular case here.
Now, I'd like to point out here that this type of process this type of chemical weathering process is very, very active upon limestone rocks. And the reason for that is that limestone rocks, they are very high in calcium, the mineral calcium, and rainwater will absorb carbon dioxide from the air, forming a kind of weak acid, and this is very, very easily dissolved. The calcium in the limestone rock is easily acted upon and reacts well with the carbon that is in the rainwater. So the carbon dioxide in the air, rain falls, the rain absorbs the carbon that's in the air, and this reacts very well with the calcium that is in the limestone rock. And so that's why the term carbonation is used, because carbon is the active agent which reacts with the calcium in the rock to weaken it. And so just like how oxygen acts upon the iron in some rocks, and hence oxidation, the carbon in the rainwater, which has dissolved the carbon dioxide, and it reacts with the calcium in limestone rocks to dissolve them slowly over time. We allow the teacher to continue.
So with carbonation, rainwater contains carbon dioxide, which produces a weak carbonic acid. The acid reacts with rocks composed of calcium carbonate. So limestone is an example that is made up of 50% calcium carbonate. So limestone will go through this process of carbonation a lot. Okay, that is how we would have all of the different limestone features being formed, like the clints and the grikes and the stalactites and the stalagmites and the pillars and the underground cave, etc. So it is as a result of the process of carbonation that would cause all of these features to be formed, because limestone is made up of 50%, over 50% calcium carbonate. So this process causes the limestone to dissolve, and it is later removed in solution. So it's dissolved into the water and then it is washed away, right? And this produces distinctive landscapes. What are these landscapes called? These limestone landscapes called? Karst landscapes or karst scenery. All right, so this is just an image of how it would take place. So this is the carbonate bedrock, and we have the rain that is constantly there. Eventually, you can see that this area would have dissolved and given us somewhat of a pond. And then water will continuously be seeping through here, so it will start giving us all of the other features in the limestone. Another example here, blocks of sugar what I actually do in class with my students to show them carbonation, we use chalk. So chalk is made up of limestone. So we use chalk and we use Pepsi. So Pepsi, yes, the very Pepsi that we drink, it is carbonic acid, weak carbonic acid. We do in class, we use chalk. We just throw out some Pepsi in a cup and put a chalk in it. And within not even minutes, within seconds, you start seeing the chalk pieces start falling apart because the carbonic acid that is inside the Pepsi starts reacting with the calcium carbonate that is inside the chalk. Eventually, everything dissolves. It just wears it away completely. Right? So that's a nice experiment that you can do with your little sister, your little brother or something, or use sugar cubes like this one. So limestone is made up of calcium carbonate. When it dissolves in rainwater, it makes a weak carbonic acid. When the carbonic acid comes in contact with the limestone and it passes through the joints and the bedding planes of the rocks, then it forms that calcium bicarbonate and it dissolves the material and carries it away. Next one is biotic weathering. So what's the prefix here again? You notice how I'm bringing up lots of prefixes or something? Those are little things that can help you to remember things in the exam. You know, sometimes you go in the exam and you get a little flustered and you feel like you don't remember nothing at all. These are little things that can help you, give you little prompts. So what's the root, the prefix in biotic? Bio. Very good. What does bio mean?
Now, keep in mind, students, that this term biotic weathering can also be called biological weathering. It's the same type, same category, same group, and it can also be called organic weathering. Organic having to do with living things. And so 3 terms can be used to mean the same type of weathering: biotic, biological, or organic. Keep that in mind.
Living things. Lovely. So if we are talking about biotic weathering, we're talking about how living things, such as plants and animals, how they weather rocks or how they cause rocks to break down. It sounds simple, don't it? Like once you understand what the word means, you can figure out your definition right away. Okay, so biotic weathering, this relates to the role plants and animals play in breaking down rocks. So we're going to look at it from 2 ends.
I would also add that it includes the action or the influence of humans as well. Remember, humans are living, so whether we're engaged in farming, whether we're engaged in mining, construction of buildings, any activities where we are engaged with breaking up rocks, by digging, by mining, by farming, by constructing roads and buildings, we also are involved in the process. Not just plants and animals, but also humans.
What the plants do, as well as what the animals do. Biotic weathering by plants. So look at the pictures that are there. Let us use this one first. We see this one a lot. So in this case, the roots of the trees, it's growing constantly, so it's moving. So it forces its way into any cracks that is inside the rock. And because it is constantly growing and it's constantly forcing its way into the rocks, it is going to cause them to expand, and eventually it is going to break the rocks apart. Follow me? So if I was to put this one with the tree on the physical weathering or on the chemical weathering, which one would I put it under?
Now, the point the teacher here is making with her students online is that biological weathering is a third category of weathering because it involves living things. But you can also fit these biological weathering processes, which are caused by plants and animals and humans, under physical or chemical, depending on what those processes do to the rock. So in the case of the roots, it's not changing the rock chemically when the roots grow and expand and crack the rock. So it would still be considered a physical or mechanical type of weathering. But once there is any chemical change in the rock by the plant or the animal or human influence, then it could be fitted under chemical weathering. So you'll find that some books will categorize weathering in just two groups, physical and chemical, while some books will have a third category. And that's the point here that the teacher is making, that you can fit all of the processes of weathering caused by animal, plants, and man under physical or chemical, depending on what happens to the rock under the influence of these living things. We continue.
Yes.
If I was to put the one with the tree, biotic weathering by the plant that is actually breaking away the rock, if I was to put it under physical weathering or chemical weathering, which one would it be? So that would have been physical biotic weathering, because it is using the root to simply break away the rock without changing the chemical composition of the rock. So what about this one now? What are these green things called? It's moss. Very good. So the moss here, it is a plant, yes, but its presence on the rock is actually causing it to break down. So the moss releases different acids, and it causes the rocks to dissolve. So anything that it grows on, it's kind of like mold on bread or something. So it releases different acids, and once it grows on it and it starts releasing the acid, it causes the chemical composition of the rock to change. So it alters the rock's chemical composition and causes it to become weak, so the rock will eventually break down. Right? So that is weathering by plants, but what other type of weathering is it?
Chemical.
Very good, chemical, because this would have been changing the chemical composition of the rock because it's releasing acids that causes it to break down. So you can see that in this one, we have chemical biotic weathering, and in the next one over here, we have physical biotic weathering. So now we are moving on to biotic weathering by animals. So burrowing animals, those are the animals that dig through the soil or the ground or through rocks. They aid in the breakdown of rocks. We have some birds that are called sand martins that burrow into sandstone cliffs to build their nest. So they will just get in there. Then we have other types of animals that, as you can see from the pictures here, that do a lot of burrowing as well. So they actually dig into it and causes the rocks to break down. Some of them do that. So this one, for example, this one, this one, this one, this one, they actually dig through. The worms dig through as well, but I'm getting to that shortly. So they actually dig through, they push themselves through the areas that will actually cause the rock to break apart. So if it is very, very, very firm rocks, it will take them some time, but they do break it down eventually. So just their actual force that is breaking through the rocks, that would have been physical biotic weathering by animals. But we do have some other animals that actually break down the rock with their chemical composition. So we have a lot of these. We have a lot of slugs. These slugs, if you've ever seen a slug crawl before, what do you notice that is behind them? So this slime that they leave behind is actually a chemical. And this chemical is what is left that will actually break down the rock. Okay? So this chemical, which is what is left, will actually break down the rock. So it is not their physical presence, it is not their actual force that is causing the rock to be weathered, but it is the chemicals that they release that is causing the rock to be weathered just the same. Earthworms can do that too, so they can burrow through physically, but when they are burrowing through, they also release chemicals. So that release of chemicals also causes the rocks to disintegrate. Okay, so that would have been biotic weathering by animals, but chemically. So I don't think Jamaican teachers do that. We teach all 3 types of weathering, but there are some persons that will only teach you 2 types of weathering. So they'll just tell you physical weathering and chemical weathering, because plants and animals can fit under physical and they can also fit under chemical. So this one here, with the use of specific examples, explain how biotic weathering can be both physical and chemical.
All right, students, so there you have it. We thank Mrs. G from her Caribbean Geography YouTube channel for assisting us with the details of this lesson. I give her full credit, no robbing her of her copyrights, full credit for her teaching material that is quite helpful on YouTube. Okay, so as we come towards the end of this lesson, students, here's what I'm going to do for you. I'm going to share with you on screen a little more detail and summary notes. While the teacher was teaching throughout with the video clip, you saw summary notes, but I'm also giving you additional information here. And as I slowly scroll the screen to show you what additional information is there to help you in your preparation, feel free to pause the screen, take screenshots if you wish, or just read what is there. So here we go.